Hello, everyone. Welcome back to SAT Math Question of the Day. For one reason or another, we missed the last 5 days. Friday, Monday, Tuesday, Wednesday, maybe 4 days. But anyway, we're back. Today's Throwback Thursday. And we will therefore, when we're done with this question, we will go back to a test question from maybe 20 years ago, which feels a lot different from the current test, and do that. So this is question 18 of a pamphlet that the SAT people give out that gives you practice questions for the new digital SAT, which will be coming in the winter of 2024 for United States high school students. Okay, question 18. Please read it, do it, pause, and then come on back. Okay, a circle. A circle. Seth likes it when it's thin. Oh, we didn't introduce ourselves. This is Professor Emeritus Seth Chaiken at the University of Albany, and Joel, I'm Seth's brother. We're here to hopefully show you how to approach SAT math questions and maybe even all math questions, or many math questions. Seth's already on top of things here, drawing the circle. A circle has center O, and points A and B lie on the circle. The measure of arc AB is 45 degrees. And the length of arc AB is 3 inches. What is the circumference in inches of the circle? Wow, there are a few ways to do this. What? I mean, I would go ratio. What do you think? What do you think? Ratio?
I wouldn't even say ratio.
Really?
I would say, okay, here's a 45-degree angle.
Yeah.
Right?
Yeah.
Double it.
Yeah,
and you get a 90-degree angle.
Right. Yeah.
And then quadruple the 90-degree angle.
Well, you can also write a 6 here.
No. Quadruple it. And 2 times 4 is 8.
Yeah.
So when the whole circle equals 8 times 45-degree angle. And therefore, the whole circumference, right,
is 8 times
is 8 times the circumference subsumed by the 45, which is 3.
Right, yeah. So
the answer is 3 times 8, which is known as 24.
Right, that's right. Well, no, that's essentially a ratio. It
is ratio.
Yeah, that's what I mean. Yeah, there are 8.
Yeah, but why? 8. This is a once you learn about the relationship between the measure of arc, right, of a circle, and the length of the arc, that the length of the arc is proportional to the angle measure of the arc.
That's right.
The more angle there is, the more length there is.
That's right.
We don't even have to think about the fact that when the angle is expressed in radians, then the proportionality constants, the proportionality multiplying factor between the angle and the length of the arc is the radius of the circle.
Yeah. There's a fancy word for that angle. It's called the central angle. This angle is the central angle. So the length of the arc, which is sometimes known as S for some reason, is the radius of the circle times the central angle when the central angle is in radians. But Seth said you don't even have to worry about that. You just have to notice that there's a direct relationship between length of arc and radius. Length of arc and angle.
Yeah.
Length of arc.
And then I thought of what I did to solve it. I thought in my mind, I thought of it this way. I thought of the 45-degree angle as being standing up like that. And then how many of them
Right.
go into the circle? Well, two of them
Seth,
go
you already did
into
that. Seth,
a
Seth,
right
Seth,
angle, and
Seth.
then multiply at four. Then it goes
Seth,
up.
you
Then
already
there are
said that.
four copies of two,
You already said that. You already said that.
which is known as 8.
You already said that. It's okay.
Yeah.
Right. So the question is, there are eight 45-degree sections in a
Yeah.
circle. By the way, that's very pizza-like, isn't it? When a pizza gets cut in
Yeah.
eight sections, then each section is actually 45 degrees.
Yeah. When they're cut equally.
When they're cut equally, right? Yeah. So a ratio problem's the way to go. I mean, you could use all the formulas, and then you get bogged down in the pi. You figure out what the should we? I don't know.
Yeah.
Some people may do that.
So what's the approach? What is the approach is visualize the relationship between the only two things that are given. That is the subsumed angle of the arc and the length of the arc along the circumference.
Right.
Right. That's the approach, and then approach it by proportionality.
Right.
Okay. What are some alternative approaches that are not as efficient?
Well,
alternative approach. Find the right formula. Pick a formula.
Right. Right. Yes. That would be the tradition. That would be a way to do it without realizing the relationship. So
yeah.
If you, by the way, there's the answer D. So if you wanted to use the formulas, you would then, you would know if you just without this relationship, the circumference of a circle is 2 pi r. That you have to know, but that may be given on the reference sheet. They're asking you what the circumference.
Well,
of a
I
circle
think
is.
you need a bit more. You need to know that the length of the arc is equal to the radius of the circle times the measure of the angle.
I know, because you didn't.
When the angle is measured in radians.
I know. So
the thing is you need to know not merely that the entire circumference is the radius times 2 pi radians. But you also have to know the relation, the idea that an eighth of 2 pi.
Seth, you didn't let me finish talking. I wasn't finished talking. I'm not done. You have to. Seth, please.
No,
okay.
I'm being annoying.
You are being annoying. You are. I used to be annoying. I'm Seth's younger brother, so I used to be annoying. Now we're switching roles. Now, but right, in order to do this, you need to know the radius. So you got to use what they tell us, the clues to get the radius. They tell us that the length of the arc is 3, and the circle is 45 degrees, and that gives us the radius. So Seth's right. You have to know a lot more stuff if you're going to go this way, because you have to use this formula that the length of the arc is the radius times the angle in radians, which means you have to convert 45 degrees into radians, which I think is pi over 4. Then you have to solve for r. Oh, what a pain.
You solve it. Divide 3 by pi over 4.
It's 12 divided by pi. So then you have the 2 pi. And then you have the 12 divided by pi, and you multiply, and you get 24. Oh, but you can do it that way. But you have to know 2 more things, as Seth so wisely said. You have to know that they have to know 3 things. The circumference of a circle is 2 pi r. The length of a sector that they call part of a circle is r times theta, where theta is in radians, and you have to know the 45 degrees is in radians. So yeah, the ratio way to go. Usually when you have problems like these, try to use ratios. This problem could also come in as an angle. No, it's an area problem. They can tell you the area of a sector is a certain thing. And they say, what's the area of the whole circle? And then you'd use the same ratio thing. It's 8 times the area of that thing.
Yeah.
Because area depends on the area is directly proportional to the angle. How big the sector. We done? Seth?
Yeah.
We're done.
Yeah.
Okay. Oh, let's see how they did it. Did they do it the ratio way What did they do with the formula way? Drum roll. Which way? Because there really are two ways to do it. Okay. Theorems related to circles to solve problems. Boy, that sounds really intimidating.
What?
Okay, they did ratios. They did ratios.
Oh,
Yeah, they did ratios. Essentially, they did
yeah, yeah,
ratios. They
yeah.
noticed that, yeah, yeah.
And they put the X in the denominator, which is stupid.
True. Granted, we talked about that in another video. Yeah, 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 yeah. But I essentially used ratios.
But it's a lot easier. Why? You could make a mistake this way.
Oh, yeah.
45, and those are big numbers.
But don't forget, you have a
Those are
calculator.
big. Ugh, they're ugly numbers. It's much faster to think of this gadget equals, that this gadget times 8 equals that gadget.
Yeah, 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 yeah. But I'm a big fan with ratios. It's always good to write the ratio. Um, but this one, it's sort of once you have a little bit of experience with this, it is faster to do it the way Seth said. Yeah, and by the way, you have a calculator. It's funny how they don't say use your calculator to do this, but because everyone has a calculator on this test. The calculator is built into the computer because you're going to be taking this test on a computer,
What?
starting in
Yeah,
those
yeah,
years.
yeah,
Okay, so should we
yeah, yeah,
move to
yeah,
Throwback Thursday? Throwback Thursday, we go back to
yeah.
a test. Actually, I got from this book, bought it on eBay. 10 SAT official test from 20 years ago.
Hmm.
But you maybe 30 years from now, this video will still be watched, God forbid. So then, this is from around year 2000 something. Maybe the late 90s, 1990s, not 1890s. Throwback Thursday question. Here we go. Oh God. Okay. Again, the test had a
Ah,
whole different feel to it. Yeah. Anyway, here we go.
yeah.
So feel free to look at it, pause it, come back, and wish us luck. Okay. If the
Should I
notation,
do it?
well, no, yeah. Okay. I guess I'll go ahead. Yeah. Oh, that's not too
Well,
bad. Oh, it's
it's a
not too bad.
pattern.
It's a pattern.
Here's I don't know, the challenging part of this is that you must do what the question tells you.
Right.
That two that they give us two examples of defining a new number from a crazy expression that you've never seen before.
Right. It's called
And
a
that
function.
method is you take the first little digit under the 2 and you make it the exponent of a power of 2.
Right.
You take the second little number that's under there and make it the exponent of another power of 2. And so for the third. And then you add them up. And so you do the same thing. 2 to the 1 plus 2 to the 3 plus 2 to the, how much? 5. Okay. Now you have to figure out each of these separate things. 2 to the 1 is 2 by itself. 2 cubed is 2 times 2 times 2, which is 4 times 2, which is 8. You figured this out. 8 is 3 2's multiplied together. 2 to the 5th is, you take the 3 2's, the 8, multiply it by 2 more times to go from 3 to 5. So that's 8 times 8 is 16, plus another 6 times another 2 is 32. And then you carefully add these up. The way I like to add them up is, I see the 8 and the 2. They add up to 10, so it's easy to write 40. Okay, 2 plus 40 is 42. And what went wrong?
Nothing went wrong. Looks like it's choice A. What
Oh,
went wrong?
okay, 42.
Yeah, nothing went wrong.
Well,
Yeah.
yeah, good.
So at first, this question looked crazy, but then when you just sort of look at it, you realize that it's really uses pattern recognition. And this
Yeah, yeah.
concept of a funky function. Funky function means you just do whatever they tell you to do. Everything is defined. Funky function. The operative word is defined, and you just do it.
Yeah.
Yeah.
Yeah, it looks crazy because this notation in this problem, I've been a long time within circles of math, science, and engineering, where all sorts of crazy notations are used for quantitative things. I've never seen this notation for this expression.
But Seth, that's what makes life interesting. You sometimes there's a new, very often actually, if you look carefully, for almost every day has something new in it.
Yeah,
So this was the new experience for Seth today.
yeah.
Yeah,
But the approach is that magic word defined.
that's right.
Well, this is an issue. This is a stumbling block. This is a stumbling block that many of my college students have suffered from.
Oh, really?
It's the stumbling block about what the word define means.
Okay, I have. Don't question it. Don't question it. It is. It goes both ways, and it
Wait,
is
wait,
what
wait.
it
No,
is.
no, no. There's a real
Okay.
difference. There's a real difference in how how in mathematics the word define is used and in English how it's used.
Well, also does this have little 3 bars or something in defined? Does it
Yeah,
have a
yeah,
three
yeah.
bar
There's a
thing?
mathematical symbol
Yeah,
for defined,
like the square
you
root of
know.
-1 is
Yeah,
I.
yeah.
Yeah, like that. Put a little thing there. Yeah. Yeah.
Yeah, yeah, yeah. That's what they would do is they use that notation. They would write they use a triple equal sign.
Means
But
defined.
the what I'm saying is the very word define.
Yeah. Okay.
Looking up find a definition by looking it up in the dictionary and by reading how something is defined in a math book mean very different things.
Okay.
Okay.
Yeah.
The dictionary definition is like a newspaper or news report. It is a report of how many people over a long period of time have used a word. So
Okay.
simply going out and seeing how a word is used among a lot of people, and then putting a description of that in the dictionary, so that in case, say, a young person who hasn't been listening to language for a long time, a kid, hears a word that's new to him or her. The kid can look it up in the dictionary and find out what people mean by that word.
Right. Okay.
Okay.
Got
In
it.
math, it's very different.
Okay.
It is in math. In math, it is like what an author writes when writing one single story.
Okay.
The author tells you tells you what person or thing in the story is named by a name that the author writes.
Okay.
So, like a story could say, Sue is a 9-year-old girl who lives in Brooklyn,
Right.
right?
Right.
And then in the rest of that story, that is what the author tells you about Sue, and that to understand the story, you have to remember and memorize and actually believe that Sue is what the author says
Right.
when you read the story.
Right. Okay.
Even though, you might have a big sister named Sue, who's 23 and lives in Chicago.
Right.
Yeah, you can you'll be in trouble if because it's in the story. So if you looked up, so you cannot find the kind of person that the author defines Sue to mean by looking it up in a dictionary.
Right. Okay.
Okay? So Joel, so this is really serious because what college students stumble over is they're taught in a math class or a computer science class or a science class. They'll be taught by the teacher, by the professor. They'll say, velocity is defined as, the amount of distance a moving thing moves in 1 unit of time. Okay, that's what, and then for the context of that subject, that is what the word velocity means.
Yeah.
Even if you don't, even if you've used it for other purposes.
Right. Yeah. Okay.
Yeah.
Yeah.
In the
Right.
same way, in this problem, a number with a bunch of subscripts is notation that's defined to be this meaning, and that's how you use it in the problem. In fact, in mathematics, subscripts are used for many other purposes.
Right. Yeah.
But those other purposes, those other definitions are given in different
Right.
stories.
That's right. That's what at the very beginning. That's what I said. You literally just follow this and don't think. You don't think about anything else. It is a self-contained thing. When you see something is defined, thinking stops. You do exactly what it tells you to do, and exactly what it tells you to do. That's right. Exactly.
Well, I wouldn't say thinking stops. Thinking proceeds using as a fact what the definition says.
Right, but to give a more intuitive feel, don't think about anything else.
The thing is that the more intuitive feel is that the author's telling you something that you might already know, and then confusing what you already know with what the author tells you.
Well, what you just said was confusing. Just when something's defined as something in a problem, you use it exactly as it's said to be, without questioning.
In the problem.
Without questioning. Maybe that's the word. Not thinking, but without questioning. You do it without questioning. Because if you start questioning, you're going to start wondering, well, someone else said it was this. No. In your problem, it's defined now. Okay.
Yeah.
I think we're done. Okay, everyone. Have a great day. Hope this helps. You don't normally see problems like this in the post-2016 SAT. Okay, everyone, have a great day. Like us, dislike us, give us comments on our YouTube videos, or email us at satmathquestionoftheday@gmail.com, and we will see you next time we meet. Take care, everyone. Bye.